Okay, so this video is being recorded as an adaptation of activity 2.3.3 in the PLTW curriculum, and it covers assigning materials and conducting interference tests within Fusion 360. So the intent is to build off of our lesson on material properties, where we've discussed what materials are and why the properties of those materials matter. And I did the density activity where you identified some samples based on their density. And so now we take that knowledge and we're going to apply it to Fusion 360. Since I have done the last PowerPoint slide, my computer has updated, and this is a very different version of PowerPoint. So everything that I'm looking at, like the controls on here, are totally different. So forgive me if I like click the wrong way, or I can't find how do I click to the next slide because it's all different. So I'm sorry about that. All right, so choosing materials in a CAD system. So we just finished a lesson where we talked about a material's properties, and we learned that it's essential for selecting a material for whatever design you're manufacturing. Properties such as density, yield strength, thermal conductivity, can be defined for a material in a virtual space to harness the powers of computers as analytical tools. Simulations based on applying a specific material to a 3D model of an object can virtually test a component's performance under specified conditions. So the idea here is, once you have an idea of what material you want your design to be made out of within Fusion, you can assign that material, and then you can have the computer perform specific tests on that to see, in theory, or at least in the simulation, how well that material will hold up. Both the appearance and properties of a material are defined by parameters. Appearance parameters include color, texture, reflectiveness, translucency, and luminescence. Material properties that can be used to describe a material include density, thermal properties, and mechanical properties. You may experimentally determine a property of a material, or you can perform academic research to find parameter values that will define a material in CAD. So basically, you can just play around with what's already there, or you can do research and import the properties that you want for a specific material. And I got to move my mouse in the other direction. Okay, so this is how we're going to start this activity. So you're going to open Fusion and then design the following. You have 25 minutes to complete this, and if you don't finish, you can still complete the activity with whatever you do design. So it's not necessary to complete the design in order to continue participating in the activity. So it's really important that if I call time before you're actually done, that you stop the design process and you complete the rest of the activity. You can go back and finish the design process later. So what I want you to do is design a dollhouse sized table with maximum dimensions of 1 inch by 2 inch by 4 inches. So it can be smaller than that, just those are your maximum dimensions. It can't be longer, wider, taller, deeper than those. It must have an eating surface with 4 legs. Okay, guys, so you have to have 4 legs in your table. You have to use a fillet somewhere in your designs. We're trying to review some of our older skills. And you must use a tapered extrusion for the legs. So you got to kind of remember how you do a tapered extrusion, and you can play around with the extrusion angle or the taper angle until you find something that you like. Keep it simple, but if you have time to be creative, take advantage of it. So we want to really hone those Fusion skills. So if you're done designing your table, or I know one of my classes this year, I put this up on the screen while you were done with your previous activity. So it could be that you've got some of this done already. So try to use some of the skills that we've covered this year, like using patterns or just whatever you might want to do to make your table, your little dollhouse table, look better. For the purpose of doing this at home, you should probably pause the video at this point, go hop on over to Fusion, design your dollhouse size table, make sure you save it so you can access it in class, and then come back to this presentation. Okay, so now we're going to assign materials as follows. So depending on your design, You can choose one body or component for this part of the activity. Either is fine. So if you did your table as one body, so it's like one solid piece, which a dollhouse table probably would be, okay, like when you consider a dollhouse table. An actual physical table, though, probably is not one piece. You've got pieces that like hinge or join together, or the legs insert or something, but either is fine for this. If your design has more than one component, be sure to use the same component for each material change. So you don't want to change components and like use one leg for one part of it and then use the eating surface for another part of the activity. So you can pick any part that you want. Right click on the body or component in the browser. So the browser's over on the left-hand side, and you're going to right click on it, and then you're going to choose physical material from that menu. Make your body or component brass. Okay, now probably you would not do a dollhouse table in brass, but for the sake of this exercise, you're going to do that by looking at brass in the menu and dragging it onto the body or component. So you're going to click on that and then drag it onto the body or component and then close the dialog box. Right click on the body or component in the browser again, and this time choose properties. Then fill out the chart on your handout and be sure to include all the units. So you can go hop on over to the activity where you'll see what it is that you need to fill in. Okay, so you're going to look at the properties and just fill in the properties from the handout. If you're doing this from home, obviously pause the video at this point, go on over to Fusion, complete this, and if you don't have access to a printer where you can print the handout, just write down the answers to the different questions on a piece of notebook paper and you can submit that in place of it. That'll be fine. All right, now you're going to repeat the process 2 more times. So the first time you repeat it, you're going to repeat it with glass. Again, probably not a material that you would use to make a dollhouse table, but we're like, remember the goal of this activity is to practice assigning materials. So you're going to repeat the process this time with glass. Be sure to unassign brass before assigning glass to it, and then fill out the handout like now with your component being assigned the glass material. And then when finished, unassign glass. Then do some research on different materials and choose one that you think would be ideal for your table. So think about dollhouse furniture. What is it typically made out of? If you say like plastic, make sure that you do a little bit of research on like what kinds of plastics would be good to use. Take a few minutes to consider the different materials. Okay, and then finish this portion of the handout by assigning the new material to your design and explaining your choice in the space provided. So you're going to explain why you chose the material that you chose, and you're going to fill out that part of the handout. And then in class, I'm going to give you about 10 or 15 minutes to complete that portion of the assignment. It shouldn't take you more than 10 minutes to explore some materials, figure out what you want to do. It's going to take almost no time at all to do the materials swap in Fusion and fill out the chart, and then a few minutes to kind of explain why you chose the material you chose. Obviously, if you're doing this from home, you're going to pause the video at this point and complete this part of the assignment. Okay, so the next thing that we're going to do in this lesson is interference testing. So if you think back to the beginning of this little presentation, and I'm only about 8.5 minutes into it, so hopefully you can remember from 8.5 minutes ago. But one of the things that you can do within Fusion is you can test to see how a particular design is going to work. So for this part, you're going to design the following in Fusion. A 2 by 3 by 4 inch prism. It does not matter how you orient it, okay? Just make a prism. And then place a 1 inch extruded cut hole in any face of the prism, and just make sure that it goes all the way through. So that's a circular cut, and you're going to go all the way through your prism. So basically a block with a hole in it. In the same file, design a cylinder with a 1.1 inch diameter. So notice that if I can find my pointer on this new layout, there it is. That your hole is going to be 1 inch in diameter, but your cylinder is 1.1 inch in diameter. So in theory, this cylinder does not fit in this hole. If this were a physical design, it would not fit. Turn both bodies into components, ground the prism. Then create a slider joint to insert the cylinder into the hole of the prism. You may need to reorient the cylinder first and then capture that position. So I think based off of some of the other activities we've done, you should be okay with doing that. And then you'll notice that Fusion allows the cylinder to insert into the hole, even though we know that the cylinder is too big. So Fusion is not going to error on you and tell you, hey, you can't insert the cylinder here. All right, so note that. And of course, if you're doing this from home, you probably need to pause the video at this point and go over to Fusion and complete this part. Now you're going to run what's called an interference test. So go to the Inspect dropdown, choose Interference, and then choose the two components and include the coincident faces, okay? So you want to make sure that you choose the two components, but you want to choose the faces that are next to each other. So that's going to be the interior of the hole that you cut and the exterior of the cylinder. And then click Compute. A box will appear that gives you the volume of the interference. So what Fusion is going to do is, because you know that that cylinder is too big, it's actually going to tell you how much volume you have overlapping, or how much volume you have like over what you're allowed to accommodate in that hole. So volume of the interference, write this in the space provided on your worksheet, and then move the dialog box so you can see the volume of the interference in the design, and then close the box. So you might have to move the dialog box out of the way. Then go back in your timeline and edit the sketch of the circle. So you need to go back in your timeline across the bottom with Fusion and edit the diameter to be anything in between 1.1 and 1.2 inches. So you're going to make the volume or the diameter of the cylinder a little bit bigger. Now that should increase the volume of the interference because you're making it even bigger. But I'm going to let you pick what you want to do. So hopefully you don't pick the same thing as your neighbor. Run the interference test again and record the volume on the handout. Then change the circle one more time to a diameter of 1 inch and run the interference test a third time and record the volume on the handout, and then answer the reflection question at the bottom of the handout. So you're going to run that interference test 3 times with 3 different diameters of the cylinder. Now, if you've got questions, let me know, but hopefully this will let you know if you've been absent from class, what it is that you missed, and give you a shot at keeping up and having some of this done before you return to class. Please let me know if you have any questions.